Good. Hello everybody, my name is Peter, and today I want to talk about cloud functions and a tool called Cloud. Can you just heads up who knows cloud functions or ever used cloud functions before?
I've heard about them.
Heard about them? Okay. So I just want to show you the showcase how cloud functions actually work in G-Cloud. They are now in early beta stages, so there are not too many features, but we can get started pretty quickly. And then we'll use CloudFunc to actually deploy our Go functions. So first things, agenda. You can find this presentation on the GitHub repository. And so first thing I want to talk about is what actually serverless is. Not many of you raise your hands, so this may be quite new for you. It will be just introductory why we actually want to use serverless. Then I'll talk about GCP functions. This is the kind of same topic. However, the serverless is just a model, and GCP functions are the actual implementation of the model with some specific features to G-Cloud. Then I'll talk about CloudFunc, which is a tool that is able to deploy Go code as functions. Then I'll demo just a simple HTTP trigger, so you can then go home and try the same demo or just write your own function that easily. And at the end, I want to talk about alternatives because there's actually AVS, there are Azure functions and all this stuff. It's pretty competitive space in functions. And the last slide will be about resources, which means where we can actually start. So first, what serverless is. So by serverless, you can actually imagine an environment that is fully managed for you. What it means is you don't actually have to deal about all the infrastructural networking and all the stuff. Everything is just there for you, and you need to just deploy your code. That easy. Why this became really popular is the pricing model of this, which means that you only pay for nearest or every time you start 100 milliseconds of CPU, you will get charged only for that amount. Which means you don't actually need your servers, like rent servers all the time. You will actually pay only for time that you actually execute your functions. Really popular feature of this is auto-scaling. This means you don't need to manage auto-scaling of your instances. Everything is managed for you. If you trigger one function per minute, it's okay. If you trigger 500 functions per minute, it's okay also. Everything will be parallel for you. And the most suitable model, which is for serverless, is event trigger, which means something triggers something, and then all the functions are triggered to and compute the result. And in this picture, you can actually see what's customizable and what's managed. From this point, like GCE, which is compute engine, which is like you get your virtual machine where you can SSH and just do whatever you want, until you get to Google Cloud Functions, where you can actually just deploy your code, it will just work, or the Firebase, which is a relational database and nowadays kind of framework for mobile development and all stuff. So there are many use cases for using serverless or cloud functions. First one is webhooks. I think everyone has that need to implement some kind of webhook. If it's Slack, if it's GitHub or anything else, you can simply use serverless or these cloud functions to trigger these webhooks and then do whatever you need to do. One of the good things is really you can actually divide
Proszę o małą network z
Okay. So one of the popular features is small burst of units of work. This means that if you actually need to compute something just sometimes it's not, you don't need the machines all the time, right? So you can just use cloud functions to trigger all the functions to do the work in some time, and then it will go just down, which means you won't pay for that. Triggers. This is actually one of the specific features, like PubSub and storage, which is implemented inside of gcloud. It means it will publish messages based on some events, or some services will publish events to topics, and you can then catch them in cloud functions and just read them. Integration with third-party services. This means kind of adapting some kind of other service to your need. Then mobile backends, and this is kind of popular right now with Firebase or Firebase functions, which means if you need just small chunks of code that you need to execute, you can simply do all the code into functions. It will just work with all other services. If it's cloud, if it's AWS or anything else, the concepts are really the same, so you can use it everywhere. Then, really good thing is if you have unpredictable load to your services, then cloud functions are really good for this. What this means is if you got like a big marketing campaign or anything like that, and your load just goes up quickly and then goes down again, this is a really good thing, a really good way to handle this load. Prototyping and production testing. These are, I'm not sure if production testing is safe, but I've seen some people actually production test functions just because they need to optimize them, because you can see all the load real time as you will see. So these are the best, or these are the use cases that I have picked. I think you can imagine any more, right? Okay, so now I'll talk about GCP functions. This is the specific implementation for the serverless. GCP functions are now in early beta. This is just informational slide, so you know what to expect when you come to gcloud and say, okay, they have functions, great. They are in early beta, which means there are not many features. Only region that is now supporting is US Central, which is not really good for Europe, but they want to add more regions during this year. So until the end of the year, we hopefully will have functions in Europe. The one thing here is Node.js runtime only, and now you can ask, okay, why are you speaking at Golang Meetup when they only support Node.js? And you will actually see that we can patch this and have Node.js runtime actually execute Go code. And this, I will actually showcase this on the next slide. There are these triggers for many services. So all services across gcloud actually have these PubSub topics that they will publish messages into, and you can just catch them. There are many more features which are now introduced by Firebase also. But these two functions, or Firebase functions and gcloud functions, are not really the same. I'm not sure if you can operate the real-time database really easily from gcloud. You can do that from Firebase functions. The one thing is that you can't right now you can't deploy Firebase function using the gcloud CLI, and you can't actually deploy the gcloud via Firebase CLI. So the one really good thing is if you actually want to use them just for your prototypes, or you're starting a new app or anything, well, they have a lot of free stuff there, right? We actually never paid for functions because there's a lot of seconds like. Sorry. Yeah. So that's not like, it's not meant for a big company, but for a small business or for just a starting project, there's quite a lot of free performance. And there are actually triggers that are now supported by gcloud. So if you're using any of these services, you can actually trigger cloud functions from the service. And now CloudFunk. Actually, I wanted to showcase just one thing really quickly on gcloud. Okay. So you can see on gcloud you can actually find cloud functions under, yeah, it's pinned here, but you can see it under compute. And the way this works is, I want to showcase just the Node.js runtime as there's no way to deploy Go code this way. But it's really easy. You can just say, okay, I want my function. This only US Central, as already told. You can have up to 2 gigabytes per function. And now there are multiple triggers. We'll now use HTTP trigger. There's our link, which we want to trigger after that. And there's also inline editor. Now, this is Node.js code, right? But you can actually prototype it pretty quickly, also using this inline editor here. And one of the things is that you must always specify bucket. Anyone heard of buckets? Yeah, okay. So buckets are just like folders. You just put content there, and they are on cloud, which means when you must actually specify your bucket where you want to store the function. And when I just say, okay, create, and I can see the function here, it's deploying. This way you can actually deploy functions really quickly. So there's no data right now. I can just create. And this environment is really great because you can actually test your function inside gcloud, which means I'm not sure what was this function. I can just trigger it like this, and it says success hello. This way, you can actually see all the monitoring also in one place. There's no data right now. It may appear then. So this is the way how you deploy Node.js functions right now. Now I want to talk about how you deploy Golang functions, and this is why I created CloudFunk, which you can see on this GitHub repository. And the CloudFunk is now in early stages, so there are many more features to come, and it supports on HTTP triggers right now. So what you've seen right now, I will now do in Golang. The thing it works, you can actually bring anything from Go ecosystem. It will just build a binary, and then you can treat it binary in gcloud. So the implementation, I won't bother you much with this, but this is just the part that's implemented, or how is the CloudFunk implemented actually, which means I'm using Node.js shim. That's just spawning the binary that you actually want to trigger. This means that any code that you compile, you can actually execute on functions. The usage is really simple here. This is the minimal code. You can actually see this in the README, which means I have some input. Then I'll just create the cloud function and have it we just bind the input that was given to us and just return it. This is like an echo function. Is that okay for you? Yeah, understandable. Cool. Now, if I want to deploy this, I already have this here in my project. The way I deploy it is there's a single command in CloudFunk that says deploy, and you give it a folder which you want to deploy. Now in the folder, you might actually have the function JSON, which I'll talk about in the next slide. But this JSON just specify where you want to deploy your function, and you need to be signed into your gcloud SDK to deploy this, as it's using your credentials to deploy all the functions. What it means is I can just go CloudFunk deploy. I don't know what was that. Meetup And now we will build the sources that are in this project and hopefully deploy them. Yeah, deploying. And hopefully we'll see the function here. Okay, I'll just talk about the next slide until it's deployed. So the configuration is really easy actually. You just specify the name of your function that you want to deploy. You specify bucket. Now this is important because you always need to specify bucket in which this function will be deployed. And another preference is memory and timeout. Maximum timeout you can have is 540 seconds, I believe. And memory is 2 gigs, as we've seen before. Okay, so it's deploying now. It may take up to 2 minutes. So we may see it here. Okay. Is there? Is there? Okay. So we just deployed the function. It's far more faster.
Yeah, it's a Wi-Fi problem.
Yeah, it's about.
I saw it with my.
Okay, so now this is just an echo function. So if you just test it, it will just. What? Okay. Yeah, you just output the empty JSON. If we give it hello world, it will give us back hello world. So this is actually really easy, right? So the function is fast. The echo function is not a big deal actually. But I want to show you one more function that we actually have, and this is a linting function. If you ever seen the CI's continuous integration tools that do lint or linting, you can also code this by yourself if this loads. I already deployed this function. Yeah, okay. And we can actually lint cloud fun itself. So I can give it. I can just give it the public repository, and hopefully it will give us back. Yep. Okay. So what happened here was it downloaded the whole repository, then started linting the repository, and gave us back the log from lints. So now we can take this. Fire. And here you can see files that were linked and all the errors. So there are errors in CloudFront, linking errors in CloudFront. This way you can implement really easily. For example, GitHub hooks that will tell you on your pull request what's wrong with the code. So this is just another example of usage or how to use CloudFront. Now the last thing that I want to talk about are alternatives. So AWS Lambda is the biggest competitor right now, as it has many features, and you can actually use Apex, which is a tool that is the same as CloudFront, but CloudFront was created because the original creator of Apex said that they won't support GCP. So that's why CloudFront exists right now. There's no connection to Cloud endpoints or what we call API gateway, I believe, in the ABS, but there will be support for that. And the next alternative is Firebase functions, but these are two different systems, so you need to know when to use Firebase functions or when to use gcloud functions, and hopefully one day they will be the same. And resources, if you want to get started, it's really easy. All the resources are on GCP documentation, which means if you just write to Google gcloud functions, you will actually get to these documentations, and really good videos or our firecasts. You can find them on YouTube. These are all in Node.js. However, you can find a lot of tips there on how to use cloud functions and Firebase functions. Okay. So thank you all. Thank you all. If you have any questions.
Yeah. What's the actual difference between the Firebase functions and the cloud functions?
Between Firebase functions and gcloud functions.
Yes.
So I think they have in their documentation that you can easily use the real-time DB and all the features like analytics from Firebase in Firebase functions, but you can't do this in gcloud. And
So what's the difference between the cloud functions and the Google App Engine in this regard?
App Engine. Okay. So cloud functions are really good for these RESTable jobs, where, for example, creating certificates, where you spend kind of a lot of time doing what's it called? SSL certificates. So when dealing with cryptography, I believe it will get easier on cloud functions, because your app engine, when you get the burst, it will just auto-scale, it's true, but it won't go down for 10 minutes, I think. And while cloud functions are priced for every 100 milliseconds, app engine and these compute engines are built every hour, which means every hour you actually start, you actually pay for every hour there.
And functionally?
Sorry?
Functionally, what's the difference?
Functionally. There are much.
Well, I'm asking because right now it's a Node.js function, and then in the App Engine you have a Go, although old version. You have a native.
There are
binary.
there are much more environments there. So you actually have Python and Go. Is there Go? Is there Go?
Yeah, there's the old 1.6 something.
Yeah, so there's Python, Node.js, and a lot of stuff. While cloud functions right now natively speak on the Node.js.
So when you showed the binary, so what are the requirements for the binary? Is it like something running Docker container, or is there some sort of limitation behind it? Or for example, how does the startup, because they probably wouldn't have it hot standby 24/7 for every single function uploaded.
I'm not sure right now if I have the actual. So this is actual the actual command that will be used. So there's Cgo. So there's Cgo enabled 0, which means you can't actually use Cgo. Otherwise, everything runs on Linux. So that's maybe the biggest limitation for someone that cloud functions don't run on Linux.
So it builds the binary locally and just uploads it somewhere. And is there some sort of limitation size on, because you can upload any arbitrary binary?
Yeah, so it's 100 megabytes of compressed data and 500 megabytes of uncompressed, which I believe is enough for a Go binary. Okay, thank you then.